All right, hey guys, we are doing the second part of this unit, which is now we're introducing to quadratic functions and their characteristics. So we talked about quadratic functions, ax squared plus bx plus c, and we talked how to factor them out into the two binomials. So now we're looking at what that graph of the two binomials being multiplied or the trinomial looks like and its key characteristics, because we're talking about a whole new function. We've talked about linear, exponential, and now it's quadratic functions. All right, so before we begin, you have this either on Canvas. You can print it out if you're at home, or if we are able to see each other at school, I have it for you as well. If you printed it out and want to know what it looks like, go back. So when you print it out, it's two sides, front and back, okay? If you printed it out, you're gonna fold right here, right to where it lines up right here. And then you're going to take your scissors and just cut the dashed lines all the way to make your flaps. Okay. So we're going to open it up and write on the inside of the flaps to fill out what my key characteristics are of a parabola. A parabola is this shape that the quadratic makes. And I'll get more into that. So let's get started. I think I'll be fine in the top corner. All right, so again, this is what it's going to look like once you have it folded. And on the inside, once you open it up, here's what it looks like. And again, we're talking about parabolas. A parabola is just this U shape. Ooh, that was bad. That we make whenever we graph a quadratic. And a quadratic is ax squared plus bx plus c. All right, so we're going to start by talking about the y-intercept. And y-intercept should not be a new concept. The y-intercept is just the point where the graph crosses or touches the y-axis. And as a reminder, this is your y-axis. The vertical line is your y-axis. Something else should appear at that time. This is where x is equal to 0. So in this case, here is my y-intercept, and it is 5 or 0, 5. And I'm also going to draw an arrow pointing toward it. So on your paper, if you have on your paper, actually draw the arrow pointing toward the y-intercept. If you're doing this just on your notebook, draw a quick sketch of that parabola and label where the y-intercept is at. The next thing we're talking about is x-intercept. And notice how it says intercepts, because unlike the line, we can actually have more than one x-intercept. So the x-intercept is the point where the graph crosses or touches the x-axis. There's your x-axis. The horizontal line is your x-axis. And it is where y is equal to 0. So in this case, we have two x-intercepts. These are also known as your roots, zeros, and solution. It all means x-intercepts. So they might ask, what are the roots? They're asking for the x-intercepts. What are the zeros? They're asking for the x-intercepts. What are the solutions? Asking for the x-intercepts. All of these mean where it crosses or touches the x-axis. And a quick acronym to remember roots, zeros, solutions, and x-intercepts is ROCS. Roots, O for zeros, x-intercepts, and solutions. ROCS all mean the same thing. So my ROCs of this graph parabola here are 1, 0, and 5, 0, or just 1 and 5, depending on how it's asking for the answer. I'm going to draw my arrow pointing to both of my x-intercepts. So again, when you refer back to this, you know exactly where they're at. My next key vocabulary word is the vertex. And from the vertex, we go even a step further in determining if it's a maximum or a minimum. So a vertex is the highest or lowest point of the parabola. And we'll get to a form where we refer to the vertex as the point H and K. H is my x value, K is my y value. So here is my vertex. Notice it's the tip of the parabola. If my vertex is its maximum, this is where the vertex is the highest point, and you label it with the y value. If it is a minimum, this is where the vertex is the lowest point, and you label it again with the y value. So in this case, my vertex is at 3, -4, and it's a minimum at -4. 4. It's a minimum because it is the bottom of the parabola. We might see the parabola going upward. So if your parabola were to look like this, see how I'm holding it upside down? Now this is a maximum. It's still my vertex, but it's a maximum at that point. And I'm going to draw my arrow again, pointing to where my vertex is at and pointing to where my minimum is at. And then my last piece is what we're going to call the axis of symmetry. And the axis of symmetry is the imaginary vertical line that splits the parabola in half. So look at your U shape. Where can you take a line and cut it right in half? So for me, that would be this case right here. Notice that that line goes right through the vertex. And we write the axis of symmetry as an equation where it's x equals the x value. So in this case, my axis of symmetry is x equals 3. Right there. Because it crosses right through x at 3, and it's that vertical line that splits the parabola in half. And we do x equals because it's vertical, bucks. Vertical lines have an undefined slope and our x equals a number, specifically your x value. The last couple of things I want to discuss is the domain and range. Okay, for that, I'm going to focus just on the graph. So I'm going to take all of the other distractors. Obviously, on your graph, you can't take away all the other distractors, but I do want to focus a little more on domain and range. So for domain, remember domain is all your x values, and we read it from left to right. So on the left starting point, you'll notice that there's an arrow. Okay, so that means it's going to go forever to the left. Then on the right end point, you notice there's another arrow. So that means it's going to go forever to the right. So when it goes forever to the left and forever to the right, so forever in both directions, this means all real numbers. And a quick way to remember this is, since I'm reading left to right, if there are arrows on my left and right, it's going to mean all real numbers. Next, to find my range. Range is your y values, and we read it low to high. So I go to the low part of my parabola, and I put that closed dot on my y-axis. My high part, all I see is arrows at the very top, so oops, wrong way. It goes on forever in the up direction. So I do have a starting point this time, and then everything above it. So that is y is greater than or equal to -4. Another way you might see this written is in words as all real numbers greater than -4. Okay, you get to try a few. What does that point refer to? What is that one referring to? In this point? Okay. What is that line referring to? Great. Now try this one. Answer a few questions on this parabola. And last, answer a few questions on this one. Okay. Now that you've done some practice on here, there's some more practice on IXL. You're going to go to IXL, you're going to search HW8 in the search bar. This should take you to BB1 characteristics of quadratic functions graphs. You have to work this one out till you get to 100. Let me show you what it looks like. Once it loads, make sure you sign in. So first one asks for the coordinates of the vertex. In this case, my vertex is at 0, 0. Submit. Other things, it asks the minimum value of this function. This minimum, you look at your y, is at 0. Submit. Axis of symmetry, the equation. That means I do have to put x equals, where can I cut it in half? At x equals -3. Submit. That's all you're doing for all of these. See if I get a tougher one. Maximum value. Maximum value. Work this until you get a SMART score of 100. This one will count out of 100 and not out of 80. What I mean by the search, if you just go to IXL, you don't have anywhere taking directly there. If you type in the shortcut HW8, notice it pops up right here, characteristics of quadratic functions. Click on that, and that brings you here, the exact same one that I was just working on for you. All right, good luck. Finish it up and do well.